Wait, what?
This is the last thing in this chapter.
Last in this chapter.
And then we're only going to do a couple sections in chapter 13 and then we're done. Oh, wait, what's the count on that? 19? 19 school days left.
School days is that?
That's including
Good deal. Alright, so factoring differences of squares. So factoring again just means to take it apart and to unfoil it or to undistribute, right? So difference of squares. We talked about this when we were foiling stuff back last chapter. So if we're going to FOIL the product of a sum and a difference, meaning if I have x plus 2 times x minus 2, what happens when I FOIL that? Yeah, because if I go first times first, I get x squared, outside, inside, and left. These guys cancel out. Remember this? Yeah, so middle terms are going to cancel out.
I didn't use that last part.
They probably forgot to put it in before I print one. Okay, so we're going to use this pattern, only we're going to start backwards. Because they are going to give us the x squared minus 4 part of it, this bit, and we're going to go back to this. Okay? So, oh, and a note, the sum of 2 squares is prime, it cannot be factored. Notice this is a difference, I have a minus in here. If it had an x squared, stop it. X squared plus 4, this is prime, it cannot break it apart. We could try, we could say x plus 2 and x minus 2 again, or like a plus and a plus, but if I did that, I have a middle term because I have a 4x in there, right? So if it's a plus, it's prime, you can't factor that. You can try, but...
So no matter what, if it's plus, it's going to be prime.
Yep. Okay, example 1 says to factor each binomial. What we're going to do, if there is no middle term, we just have a square term and a plain number, is we're going to look and we're going to see if we can take what's called the square root.
5.
Right, because if I take the square root of 25, I get is 5. And if I take the square root of n squared, square root and square cancel out, so I'm just left with n. Okay, so I know that I can say this is n and n. This has to be a plus and minus. Okay, if you are not sure, we can always FOIL. So let's FOIL. First times first, outside, inside, last, and these cancel. So yeah, we're okay. Okay? Alright, let's look at part B. So we have no middle term. We have 2 pieces that are squared. So what is the square root of 36?
6.
Okay, 6x. Because the squares and squares cancel, so I have 6x. How about
7.
49? 7y. Squares, squares cancel on that one. So I'm going to have a plus 7y and a minus 7y.
That's pretty easy. These are just binomials. Is it going to go to trinomials too, actually, or no?
No, this is just trinomials. To use that pattern. This is for binomials. Just like it's the binomials.
So calculus, it should be a pretty easy lesson.
Okay. Alright, if the terms of binomial have a common factor, there is some factor GPS has to be factored out first before we do anything else. So if we're looking at this, what can I pull out?
12.
12a. Yes. What are we left with?
4x squared minus
1.
Okay, so then we just ignore the 12a. If I'm looking here, I have a binomial. Can I take the square root of both sides? Or each piece, I should say?
No. Yeah, square root of 1 is 1.
Square root of 1 is 1. What's the square root of 4a squared? 2a. So I'm just going to leave this 12a out of the here. So I can split it. I can say 2a plus 1, 2a minus 1. And again, if you're not sure, FOIL it and then distribute to see if you come out What you got?
So we need to have the 12 in on there.
Yes. Questions on that one? Okay. Occasionally, the difference in square cutting is applied more than once to back a binomial or a polynomial completely. So if we're looking here, first of all, is there anything that we can take out of both numbers?
2.
2 on the outside, I'm left with x to the 4th minus 81. Okay, we got a binomial. Can I take the square of 81?
Yeah, it's 9.
It's 9. Can I take the square of this guy?
No, not yet, because it's not squared.
Okay. Let's think about it this way.
Yeah,
X squared. Because I want to get x to the 4th. If I'm trying to square something, can I put something in here to get x to the 4th?
X squared.
X squared. Because remember, if I have a power to the power I,
X squared.
multiply.
Sounds weird.
Yeah, square, square. If I square, square. I'm going to add the exponents to get, or multiply the exponents to get 4, right? So the square root of this guy would be x squared. So I'm going to have a 2 on the outside, and I'm going to break this guy into the difference of squares. So I'm going to have x squared plus 9 and x squared minus 9. Is anybody confused by what we just did?
No, we have to factor it in. There's some square.
Well, let's see. Can I break down this guy with a plus in it?
Yes.
You can do x plus 3 and x minus 3.
Okay. X plus 3 and x minus 3. Let's boil this back. First times first, outside, inside, and last. Am I going to get back to this?
No.
What did we talk about if I have a plus in there?
Oh, it's squared.
Ah, it's prime. But can I factor this in with the negative?
Yeah.
Yeah, because that's what this is, right? These will cancel. And I've got a negative 9. So this can be broken down. This one is prime. You can't break him down anymore. Yes?
Yeah.
Okay. So this one, this guy breaks into x plus 3 and x minus 3. But this one has to stay. He is prime. He can't be broken down anymore. So that one is factored completely. If you had just left it at that step, it is factored, but not factored completely, so you would be counted off points off. It's not all the way up.
So you have to keep the prime one.
You have to write it in there, yeah. Because if we were going to multiply everything back, we have to get back to if this guy goes away, then. Alright, is anybody mind blown on that one? Do I need to walk through it again?
Mine.
There's something I'm confused about, is how is x squared plus 9?
Because we just said we can't break it apart, because the plus tells me that since 9 is like my end term, I have to have a plus plus or a minus minus, right? And if I have a plus plus or a minus minus, the middle terms won't cancel out, and I will have something in the middle, and it will be a binary. Got it? Good. Okay, next one, on the back here. Asks us to factor this. What shall we do first?
Go 5.
Take out 5.
Squared.
No, only 5.
Do I take out 5x squared?
Squared. Yeah. Oh, no.
No, just 5, because we
Just
got a
5.
9 and 15 out there.
Thought we were breaking into 2.
Just x. I'll roll 5 there. Okay. Now what?
No, the one that you can break down is 3x whole.
No, because you can't break up 2x.
Okay, I'm giving you a hint. How many pieces do we have in the brackets? 4. What
So
do we
you
call
break
it?
into
What do we call that when we're pointing?
The
The grouping. Yeah, with the grouping. Okay, so I'm just going to keep this 5 in the front. So if I look at these first two terms, what can we take out?
X.
2x.
X,
X squared.
You can take out x squared, yeah? What do we got left?
1x plus 3.
Okay, so that would be these two terms. How about these two terms?
Can we take that
What would you take out?
down?
x plus 3. And then our parentheses are going to be the same, right? So then what do we do?
X squared minus 1 and then x plus 3.
Okay. Are we done or can we go farther? Can we go farther?
Yeah, x squared.
Okay.
X squared.
I'm going to break down the big part.
Take it x times x minus no.
So x minus 1 and x plus 1.
Will that work? One of that. Does it work?
Yeah.
Yeah, because we got x squared, middle terms cancel, 1 times negative 1 is negative 1. Can we break down this one?
No.
No. And then we just put the 5 in here. Or
You have to put it in brackets.
no, right. I do that just to remind myself that I'm working with the inside stuff and to ignore the stuff on the outside, but no, the brackets aren't necessary.
Okay.
Questions, comments? Okay, last one. As before, you can apply the zero product property to an equation that is written as the product of any numbers with factors set equal to 0. So I'm sure you're being sick of the zero product property because we've been using it in the last 4 seconds. But still, we're trying to get things equal to 0. We're trying to say that things are multiplied, so we set each of these equal to 0. So in this case, I've got squared and I've got a plain number. Can I take the square root of both pieces?
What do you mean the square root of
You just put it in as a pair.
We just think, can I take the square root of 9 and the square root of 16?
3 and 4, so 3/4?
So 3/4. What's the square root of p squared? P. So how am I going to write this?
3 minus 4, 1.
Then what?
Find out what P is.
So equal to 0. So p equals positive 3/4 and p equals a negative 3/4. And remember, if they're the same number and one's positive, one negative, you can write the shorthand plus or minus 3/4 if you only wanted to write it once. This one would be the same thing as that one. I personally would write it as plus minus, but that's just me. All right, how about B? What are we going to do with it?
Subtract 4x over.
Okay. So then we've got some weird stuff going on there. No way.
Nothing new than we're going to take out great factor
You can take out a greatest common factor. What was it?
2x.
2x, because they're both even numbers. So I'd have 9x squared minus 25.
Okay, then 9x squared.
Oh, yeah, you can do the
It'd be 3x
3x minus 5.
and then 3x plus 5.
And then 3x plus 5. So that's what this breaks into. Make sure you get your 2x on the outside, right?
And then
3x minus 5 equals 0, and 3x plus 5 equals 0.
Well, this guy.
what did you just need?
You factor it out from distributed.
Because the zero one property goes when we're multiplying, right? In this case, we had 2 pieces we're multiplying, so we'll split it up. How many pieces do we have here that we're multiplying? 3, so we're going to split it here and here. So we're going to say each piece equals 0. So this equals 0, and this equals 0, and this equals 0. So if I solve this first one, what's that?
0.
Negative 0, 2, 0,
0.
0. 6.
Divide by 2.
Oh, yeah.
0 divided by negative 0. So x equals 0 here. What is x equal to the next one?
1 and 2 thirds.
3. And this one is
Negative.
negative 5.
get at negative stuff. Pretty much anything in algebra is incredible. It just takes time.
But it's just not that tired.
What's
Yes.
26. You didn't get a piece.
Look at it in a second.